Hello everyone and welcome to Unreal Engine 5. We're excited for you to start using the next generation version of the engine and can't wait to see what you create with it. Of course, not everyone is starting their projects from scratch in UE5. Some of you have already started working on your projects in UE4 and are probably wondering whether or not you should upgrade your project from 4 to 5. This video should hopefully help you make that decision and smooth the path as you go through the upgrade process. The great news is that unlike Unreal 3 to Unreal 4, you can in fact upgrade projects from Unreal 4 to Unreal 5. It is not, however, as simple as right-clicking on the U project file and switching engine versions, and we'll show you some of the additional steps you'll need to take in order to fully convert your project, highlight some potential issues to be aware of, and offer some guidance on workflows to help you expedite the process. But first, let's talk about when and why to convert or use UE5. If you're just starting your project today, then we highly recommend starting your project in Unreal Engine 5 to be in a supported version of the engine that we will continue to improve and to develop in the years to come. UE5 is production proven in Fortnite and The Matrix Awakens, an Unreal Engine Experience demo, which we launched at the end of last year. If you haven't seen it, definitely check it out. There are numerous factors that will influence your decision, and we hope to provide you with the information you need to make it. If you are developing a game, we've got a number of amazing new features that will empower you to develop immersive experiences that you'll surely want to take full advantage of. From Lumen to Nanite and everything in between, there's a lot to be excited about in Unreal Engine 5. If you were using the engine for other projects, ranging from film and TV shows, animation, architecture, or product visualization, it's worth noting that some features of Unreal Engine 4 will continue to be available and function just as they always have, or have seen some improvements. GPU lightmask baking, switchboard, multi-user editing, and the new console variable tool all improve the experience of operating an in-camera VFX stage, for example. However, some new UE5 features may not fully support all use cases. For example, Lumen and Nanite have not been fully tested in in-camera VFX workflows or are not supported with the Path Tracer or VR. We will of course continue to improve these features and their support over time. With the upgrade to a new major version, some features have been deprecated or removed altogether. World composition levels will need to be updated to world partition, cascade particles will need to be converted to Niagara, and so on. We understand that the conversion will require a fair amount of effort, and hopefully this video makes the process a little easier for you. When converting your project to UE5, it may make more sense for you to upgrade from the current version of your project straight to UE5. If you were to update version by version, you may end up doing extra work to get your project working in each of those versions before you finally get to UE5. We think it's better to get it all out of the way at once, although this is something we suggest you evaluate carefully with a backup copy of your project before committing to a path. Even if you're just thinking about upgrading your project from 4 to 5, we recommend you do so as soon as possible. The longer you wait, the harder it will be to upgrade as more and more things change in Unreal and UE5 diverges further and further from UE4. Some of the key benefits of upgrading, of course, are access to our new rendering features like Nanite, Lumen, and virtual shadow maps. Nanite is Unreal Engine 5's new virtualized geometry system that uses a new internal mesh format and rendering technology to render pixel-scale detail and high object counts. It intelligently does the work on only the detail that can be perceived and no more. Nanite's data format is also highly compressed and supports fine-grained streaming with automatic levels of detail. What's more, Nanite can be beneficial for even very low-resolution geometry. Any static mesh that has opaque materials without world position offset can be Nanite, and anything that can be Nanite should be Nanite, since it will have benefits for both runtime performance and memory usage. Lumen is Unreal Engine 5's new, fully dynamic global illumination and reflection system that is designed for the next generation. Lumen is the default global illumination and reflection system in Unreal Engine 5, and it renders diffuse interreflection with infinite bounces and indirect specular reflections in large, detailed environments at scales ranging from millimeters to kilometers. With this new global illumination system, it's possible to achieve incredible visual results with fewer lights and systems, while at the same time improving iteration times since the system reacts so quickly to your changes in lighting. In addition to the new lighting and geometry streaming technology, we've also introduced a new method for casting dynamic shadows, called virtual shadow maps. These are very high-resolution shadow maps, and to keep performance high at reasonable memory costs, virtual shadow maps split the shadow map into tiles or pages of much smaller size. These pages are allocated and rendered only as needed to shade on-screen pixels based on an analysis of the depth buffer. The pages are cached between frames unless they're invalidated by moving objects, material effects, or light, further improving performance. These perform exceptionally well with nanite geometry, because nanite geometry can be culled and occluded at a finer granularity. So when the system is drawing shadows for a given page, it only considers a smaller set of geometry that overlaps that page, even if the instance is much larger. Additionally, nanite's automatic level of detail ensures that the triangle density matches closely with the resolution of the given page. So now you can have high-resolution dynamic shadows much farther out into the distance without causing significant performance problems for your project. With all the powerful new technology behind Unreal Engine 5, let's take a look at an example of converting a project from Unreal 4 to Unreal 5. My colleague Galen Davis is going to show you how he upgraded Quixel's abandoned apartment environment to use the new features in the engine. Take it away, Galen.
All right, so let's start converting this scene. So the first thing I'm going to be doing here inside the marketplace is actually looking for the actual environment that we're going to be working with today. So what I'll do inside the marketplace tab is actually just go up to search products, and I'll type in Quixel here at the top. And I would really encourage you guys to take a look at all the free content that we offer here inside of this section. But today we're going to be focused on the Megascans Abandoned Apartment project. And I already have this scene downloaded as per 427. And so that 427 scene already exists on my drive, and it's really easy. After you've downloaded it, you can just create a project. You can have the launcher create the project using 5.0, and that's one way you can actually just start by opening the scene and getting going with 5.0. The other way you can do it is, since I already have the scene already downloaded on my drive, I can just tab here to where I have it locally. So this is where the U project lives on my drive. And I can right click this guy and just say open with. And I've already gone to the binary section folder where I've actually targeted the Win64 version of this. And I'm just going to go ahead and select Unreal Editor here. All right, and so what this is doing is just pulling up the scene here in the background, and it's going to load everything as it currently exists in 427. So one of the things that we'll be able to see here in a second is that ray tracing is actually enabled in this scene. And this is something that we're actually not going to be using for the 5.0 version. We're actually going to be converting everything to Lumen. We're also going to be working to establish any mesh in the scene that can use nanite. We're going to convert it to nanite using the nanite audit tool and some other kind of cool tricks here inside the editor. All right, and so the first thing that I want to do here is actually go up to my project settings. And what we're going to do from here is actually start to change some of the things that we want to do today in order to improve the visual fidelity of this scene and use some of the new features here inside of UE5. So I'm going to tab down to the rendering section here. And the first thing I'm going to do is actually go down here to Dynamic Global Illumination Method. And I'm going to set this to Lumen. And what you're going to get here just to start are a couple different flags. And this will tell you that there's a couple different things that need to be activated here in addition to just changing dynamic GI here in the project settings. So I'll click OK on all this stuff. You're seeing we're going to generate mesh distance fields and a couple different things, but the key is that we're going to have to restart the editor now. All right, so we're here back in the scene, and the first thing you're going to notice is that all those warnings that we had before are now gone. So a couple different ways that we can actually check this just to ensure that we're actually going to be working from the right starting place here is I can go up to a couple different visualization modes that will actually show you that we're actually working with Lumen in some of the new systems. So the first thing I'm going to do under the Lit tab is go down to Lumen and look at Lumen Scene. Now what you're going to notice here is a kind of primitive version of what the scene actually looks like from a lighting perspective. So Lumen Scene is basically just showing a really rough approximation of what's actually going on here. And what it's going to show is just how the bounces are actually working in certain parts of the scene and what areas we need to kind of make some modifications. And so we'll go into some of those specifics here a little bit later. But the next thing I want to show is actually go down and look at, in the visualization tab, you can look at mesh distance fields, okay? And I'll switch this back to unlit so that we can see, or lit mode rather, so we can actually see the distance fields here in this viewport. So this doesn't look like a ton of information here to start, but this is actually super informative here as far as the density of the voxels that actually go into creating the mesh distance fields. And we can actually look to improve this later on, but we'll come back to that a little bit later. Okay, so we're going to start by actually going through and deleting all of the lights in this scene. And I'm going to hide a couple of these here on the side. These are just some ambient boosters that we might come back to at a later point. But for right now, they're just not super important. So I'm going to delete the directional light and the skylight here. And I'm also going to go through and delete the light mass importance volumes. And like I said, I'm going to hide some of these other light transmission boosters that we've placed in the scene. And I'm also going to do away with the skybox. So I'm going to go ahead and delete that. So if I switch to unlit mode, you can see that we really only have just the cameras and the geometry that are sort of making up this scene. And we're going to go through now and start to reintroduce these new systems back in with some of the newer systems in UE5. And this specific project was actually created before the Sky Atmosphere system was even implemented into the engine. So we're going to be able to actually drag that in today and use that system to light the scene. So let's go ahead and get started here. Again, we've got nothing in our scene here, no post-process. We've got no lights in here whatsoever. We're just going to really kind of start from scratch. So the first thing I'm going to do is actually go to this new quickly add to the project tab up here at the top. And I'm going to go down to visual effects. And the first thing I'm going to drag in is actually the Sky Atmosphere system. And if you just go to lit mode, you won't see anything just out of the box with that. We need to actually add in a couple hooks that will allow us to actually use the Sky Atmosphere system. So the next thing I'm going to create is actually a directional light. And while we're here, why don't we also just add in a skylight? And these are kind of the main components that we're going to be working with here as far as relighting our scene with lumen. So first thing I'm going to do is actually make sure that both of these lights are set to movable. And I'm going to scroll down here in my directional light, and I'm going to find the tab here that shows that we want to use this light specifically with our Sky Atmosphere system. So if you look into the Sky Atmosphere and Cloud tab, you'll see that the atmosphere sunlight is actually ticked on. And we want that ticked on because we specifically want to be able to use the sundial in relation to the Sky Atmosphere system and the directional light. We're also going to make sure that we have cast shadows on clouds activated and cast shadows on the atmosphere. And we can make sure, with these different checkboxes, depending on if we do introduce volumetric clouds, we can turn those on or off here. We also have the opportunity to take a look here with the skylight to make sure that we're getting ambient occlusion from the actual clouds here. So if you just scroll down here, and you can even just do a search and make sure that cloud atmosphere or cloud ambient occlusion is checked on, that's another possibility if you want. So those are the main features that we're going to be looking at. So I'll go back to lit mode. And as you can see, we've got our sun here over in the horizon. And we want to actually move this now to where we get the sun kind of pouring in through the main window here. So now that this light is set as our dominant directional light, we can actually go in with Control L and actually move the sundial around, which is just awesome to see in real time here. Just seeing all the global illumination in real time start to update here in our scene. So I'm just going to find an angle for this that I kind of like, that's bringing a decent amount of light into the scene. And I think that this is looking pretty good here. So why don't we go now to our skylight and just bump up some of the intensity on this light here. So I might set this just to 2. And this is just going to fill in some of the areas that might otherwise be a little dark. And the same thing with the directional light here. We can start to play with the intensity of this. I might bump it just to 15. Just so we bring a little bit more light into the space here. I really don't want a ton of super dark spots in this environment. We're going to do some material changes in a little bit, but just to start, I want to make it so that we're actually getting a really solid starting place here. So again, I can go and start to preview what the lumen scene actually looks like. So if you want, you can go down here to visualize, and you can take a look at the mesh distance fields again to just sort of check on the quality of the distance fields as it relates to the actual assets. If you might find that there's some weird shadowing, we can go back to lit mode here and check out under lumen, the lumen scene. And we can start to get a good idea of what is working and what is not working here in our scene. All right, so now that we've got our lighting basically stubbed in for the purposes of this demo here, now we want to actually go and indicate that the assets that can use nanite should in fact be using nanite. And one really quick way to do this is actually just go up to the Tools tab, and you can scroll down to Nanite Tools. And Nanite Tools will actually allow you to take a look at assets that are all throughout your scene, and it will start to actually give you an indication of whether or not the asset is using nanite or is not using nanite, and which ones have problems based on their current setup. So what I'm going to do is actually go over here to the Optimize tab here to start, and I'm just going to set my triangle threshold to 1. And what this will do is actually allow me to take a look at all the assets here specifically that are not using nanite that could in fact use nanite. So what I'll do, since we've got this long list of assets here, is I can just go to the Enable Nanite section here, and this will go through and start to process these different assets so that they will start to build proxies for them and start to make it so that everything in our scene is actually using Nanite. So I'll fast forward here a little bit, but just know that everything is being processed behind the scenes. And when we come back, we'll have everything set up to Nanite that could be set up as Nanite. All right, and we're back. So now everything that can be Nanite is set to Nanite. And what's really nice about this is that you can just go through and batch process a huge amount of assets without having to go through individually and indicate which assets should or should not have that designation. The only thing I would make sure to caveat here is to review the documentation specifically around the elements that are not currently supported by Nanite. We're obviously updating this as new developments come in, but some of the things to be aware of just with this scene specifically is that there were some world position offset elements in some of the materials and two-sided materials on some components. Those are, as of the recording of this video, need to be deactivated. So just something to be aware of specifically as you're going through and making some of the same changes that we're making here. I would also make sure to take a look at a lot of the documentation around how to make your scene better as it relates to Lumen. So I'm going to show one really simple example of how to do this. So with this hallway back here, one thing you may know is that this entire hallway is set to one single piece of geometry. Now, this isn't necessarily that problematic, just in the way that scenes have been created in the past. But for Lumen, we can actually increase the visual fidelity of these types of environments by indicating that these different pieces, these walls, could actually be separated in a sense. What we're going to do to start is actually open up the modeling toolkit. So if you go to the select mode tab here at the top, you can go just to the modeling section. And what this will do is open up a brand new window for you. And there's a lot of different tools in here. I definitely encourage you guys to take a look at all the different components that make up this specific window. But today we're really only going to be focused on one specific element of this right now. So with my hallway selected, what I'm going to do is actually go to the triangle select section here under try model. And what this will do is allow me to now start to select based on a couple different elements here. So what we can do is selection mode here. I'm actually going to change this to all within an angle. And just out of the box, this works here because this angle is set to where I'm only getting just this designation of, this degree angle specifically on this wall. Now, the only thing I need to do now is actually just go here to separate. And separate will make it basically its own component altogether. So I'll click accept. And now you can see if I just hit Control B on the keyboard, I can actually tab to this asset here. And you can see that now this wall is separated out as its own component. Again, I would refer back to the documentation specifically around Lumen to show why this is important. There's a lot of different reasons to actually go and separate these pieces out. The main reason being here for this example that we want to increase the visual fidelity and also make it so that we're feeding Lumen all the necessary things to make it do its job the best that it possibly can. So just one more time here, since we have a couple other sections that would actually need this. So I'll just show it here just on one more piece. So what I'll do again is just go up to triangle select, and with the all within a certain angle, I can just select this wall here, and I'll go ahead and click separate here and click accept. And that's just one of the ways you can go and start to make improvements to the visual fidelity with regards to Lumen. But I would highly recommend looking at all the documentation specifically around the surface cache and why it's important to break up walls like this specifically for interiors. Another thing that you can do is actually go in and start to adjust materials here. It's really important to make sure you have really bright albedos in order to kind of get the necessary bounces here that you want for your scene. So just looking back here at this hallway, you may notice that this trash can seems just a little bit darker than some of the other elements in our scene. So with the Megascans material, you can actually go in and start to affect the albedo tint here. And you can also go in and start to affect the intensity of this tint. So since I have it just set to white, if I multiply it by 2, that will just increase the brightness of this asset 2x. And again, I can go through and do this for a couple different assets in the scene. This is just something that will just overall make it so that Lumen is making sure that it's getting the best possible information going in and make it so that all the bounces are being maximized. And I would make sure just to do this on any element that you feel looks a little bit dark for the purposes of the environment that you're working inside. All right, and the last thing that I want to touch on here today is actually bringing in the cinematic high master versions of all the meshes that we're looking at today. And this is one of the features, in fact, of being able to sort of work with Nanite, and bringing in all the additional triangle detail is something that will really increase the overall visual fidelity of everything that we're looking at here in our scene. So let's use this table here as our subject. So what I want to do is go ahead and make sure that I have the standalone bridge version installed on my PC. And I'll go ahead and tab to that now. All right, and here we are inside of Bridge Standalone. And what I'm going to do, since just for the sake of time and expediency here, I'll go to my local tab. I already have this asset downloaded, but one thing you can do just to ensure that you do have the highest resolution version of this asset is actually go to your download settings inside of Bridge Standalone. And you can go to models and just make sure that high poly source is currently enabled for this download. One other thing to note is that when you're working with the Cinematic High Master Mesh, you want to make sure you're using the normal bump component as opposed to the normal map. So that's just one note to make sure that you're getting the best possible look for these assets. So what I'm going to do is actually go to the files around this asset. So if you right click on the tile, you can just click go to files. And what that will do is actually indicate that you have a folder here with all the necessary components in. So I'm actually just going to copy this location on my drive. And I'm going to tab back over to Unreal. So one quick note as far as the order of operations here. One thing that's really important is to make sure that you already have this asset designated as Nanite. And so one way we can check this is actually just go into the actual asset here. And you'll see at the top that Nanite is currently enabled. So that's the first thing you're going to see in the top left corner here. And that's just really important because if you do it without having Nanite enabled, then it will actually take a much longer time in order to import the asset and convert it to Nanite. So again, make sure that you already have this asset set as Nanite. And then what we're going to do is actually re-import with a new file. So I'll right click on the asset and I'll re-import with a new file. And then I'm just going to paste my directory here directly into the search tab. And I'm going to indicate this is the high resolution version that I want to bring in. And I'll go ahead and click open. All right, so we've successfully re-imported this asset. So if I just go and inspect this asset here inside of the viewer here for the static mesh, you can see that we have over almost 2 million triangles actually with this asset. And it's just a much higher resolution version of this asset than what we had before. So this is something that you could do over and over and over again inside of the scene until you get all the necessary components at the resolution that you're looking for. One other thing that you could do specifically with an element like this floor is actually go in and indicate that you want to displace the asset specifically by using the displacement associated with that material. Inside the modeling tools, there's a really easy way to just grab a displacement map that's associated with the tiling texture that you're looking at, and then displace it basically just from that map inside of the editor. All right, and then just to wrap up, I went ahead and just made some modifications to some of the camera settings specifically with this environment. So why don't we go ahead and take a look at the end result. All right, guys, well, thank you so much for watching this section of the video. We've got a lot more UE5 content coming. We're really excited to share it with the community. As you saw with this scene, we were able to just quickly take a UE4 scene and convert it to UE5 and increase the visual fidelity. And in this instance, we were actually able to increase the overall performance of the scene as well. Moving from the real-time ray tracing setup that we had before and converting it now to use Lumen just really makes a significant improvement just as far as the overall frame rates for this specific scene that we're working on today. Okay, and with that, I'm going to pass it right back over to Matt.
Thanks, Galen. Since every project is different, we also wanted to talk a bit about some of the other aspects of your project that may need to be upgraded once you get your project into UE5, including updating your assets to Nanite, virtual shadow map performance considerations, converting your existing Cascade particle systems to Niagara, converting your maps to world partition, how the new double precision large world coordinates will affect your project, and some deprecated UE4 features that have now been removed from the engine. We'll also include some handy tips on how to identify these issues that may need to be addressed as part of your upgrade process. To help you identify candidates for conversion to Nanite, we have the Nanite Audit tool. This works only on static meshes loaded into memory though, so if you want to check all the static meshes in your project, you'll need to get them loaded into memory. The easiest way to do that is to go to the content browser, click on the content folder, and filter for static meshes. Then you can hit Ctrl-A to select all, then just right-click. This process is much faster than it was in UE4, so even on larger projects, this shouldn't take much time at all. Now you can go to Tools, Nanite Tools, and switch over to the Optimize tab. This will show you all the static meshes that should be Nanite. You can also lower the triangle count threshold to make sure you're getting everything in your project. Then all you have to do is hit the Enable button in the bottom right corner. This process may take some time depending on the number of assets that need to be converted and the polygon density of those assets. So sit back, grab a coffee, maybe check out Chris Murphy's guided tour of Unreal Engine 5 or any of the other UE5 videos that we've released. Nanite may not be available on all platforms though. Nanite will generate what are called fallback meshes, which use the base Nanite proxy as effectively LOD0. Then, depending on the number of LODs you've set on the mesh, either explicitly or through the LOD group, it will generate additional LODs that will be used in the event Nanite isn't available. You can easily set the LOD group of a lot of static meshes really quickly using the bulk edit via property matrix tool, like so. Alternatively, you can now set either the LOD group or explicitly the number of LODs through an editor utility blueprint using the static mesh editor subsystem, like I'm showing here on screen. This is an asset action utility, so it'll show up in the context menu when I right-click on the asset in the content browser. Now that you have Nanite set on your static geometry, you may consider importing higher resolution meshes, since Nanite will handle streaming the necessary geometry on screen at any given time. Depending on the size of your project, you may consider automating this process, and there are numerous ways to go about this. We understand that content management will differ from project to project, but however you choose to go about it, you'll definitely want to make sure that you've checked the Enable Nanite Support checkbox on the mesh before you trigger any kind of import. Perhaps the simplest solution is to export the new Nanite resolution mesh to the same FBX location as the original, and trigger a re-import on those meshes through the right-click menu in the content browser. You can select multiple assets and re-import them all in one go instead of manually re-triggering this per asset. Of course, with the increased fidelity of geometry and higher triangle counts comes disk space considerations. We look forward to continuing to improve on the memory footprint of Nanite assets and recommend that intermediate formats such as FBX are not part of the set of data downloaded by most users from source control. On the runtime side of things, there's some good news. Because of Nanite's specialized mesh encoding, its size in memory is significantly smaller than the standard static mesh format. For example, this 2 million triangle cliff from Quixel Megascans is 226 megabytes as a normal static mesh, which includes all of its LODs. However, if it uses Nanite instead, the maximum streaming memory allocation will be about 35 megabytes. As you transition more assets to Nanite, it may make sense to turn off hardware occlusion queries in your project settings. Traditionally, you'd want to leverage occlusion to make sure that the GPU is only rendering what it can see on screen. The trade-off is that it takes some amount of time to calculate that occlusion. Generally, if the amount of time to calculate the occlusion is less than the amount of time it would take to render the occluded geometry, this will be beneficial. In UE5, Nanite has its own internal occlusion and culling, which doesn't use the traditional hardware occlusion path. That means that in a scene with a combination of Nanite and non-Nanite geometry, it may take more time to calculate the occlusion from the non-Nanite geometry than it does to just render the non-Nanite geometry occluded by other non-Nanite meshes. Nanite geometry also performs exceptionally well with the new virtual shadow map system because of this special occlusion and culling. However, since non-Nanite geometry can only be occluded and culled at the instance level, the same large rock will be fully drawn, often multiple times if it touches multiple MIP or clip map levels, even if it only casts a shadow into 1 or 2 pages. Additionally, certain circumstances can cause a cache page to become invalidated, which means it'll be redrawn for that frame. This includes world position offset, even if it doesn't change every frame, pixel depth offset, deforming skeletal meshes, or moving static meshes. Consider, for example, a tree. In 5.0, it can be somewhat expensive to cast shadows from a tree for 3 reasons. Nanite doesn't yet support world position offset and masked materials. World position offset causes cache invalidations, and non-Nanite geometry is more expensive to draw in virtual shadow maps. So a tree, which is not Nanite and is constantly invalidating shadow cache pages, can cause significant performance issues. We can see that if we go to the View Modes dropdown, Virtual Shadow Map Visualizations, Cache Pages. Each of these squares represents one cache page, and the green ones are valid and the red ones are invalid. As mentioned before, we fully intend to continue to improve the technology underlying Unreal Engine 5 in future releases and are aware of some of the existing limitations. For the time being, however, we have some controls to help you mitigate the performance impacts of things like foliage. Let's take a look at this simple scene in UE4. I have these trees spaced out every 1,000 units or so, and they're casting shadows into the Cascading Shadow Map system, which is composed of 3 sections. Cascading Shadow Maps, which are the fully dynamic shadows cast into a series of cascades that cover the distance between the camera and the dynamic shadow distance movable on the directional light. Then, distance field shadows, which are static shadows cast against the distance field representation of the mesh. These cover the distance between the dynamic shadow distance movable and the distance field shadow distance. Finally, far cascades are dynamic shadows cast from a limited set of explicitly included objects that cast into far cascades from the distance field shadow distance to the far shadow distance. In Unreal Engine 5, we've got some similar concepts and added a new console variable to help as well. For non-nanite geometry, the different shadow stages look like this. From 0 to r.shadow.virtual.cache.max material position invalidation range, all shadows cast from potentially deforming non-nanite geometry, i.e. world position offset, pixel depth offset, skinning, etc., will cause the cache to be invalidated every frame. This means the shadows from things like trees will move and sway as the tree moves and sways. From the max material position invalidation range to the directional light's dynamic shadow distance movable, material effects will not invalidate the cache. So while the engine will cast shadows from the material, meaning you get nice dappled lighting through the leaves of the trees, the shadows of these objects may update unpredictably, or not at all, as the object animates. Beyond the dynamic shadow distance movable, the virtual shadow map system will use the distance field representation of a mesh to cast shadows up to the distance field shadow distance. Beyond the distance field shadow distance, no shadows will be rendered from non-nanite geometry, with the exception of the following note. Anything that's set to far shadow will be rendered into the virtual shadow map out to the maximum virtual shadow map distance, regardless of dynamic or distance field shadow distances. Nanite geometry, however, will cast shadows into VSMs all the way out to the maximum VSM distance. The Cascade particle system from UE3 and UE4 is being deprecated from UE5. You will need to convert your existing Cascade particle systems to Niagara as soon as possible, as these will no longer be supported in a future version of Unreal Engine 5. To aid you in the process, we've created a Cascade to Niagara converter tool, which is a plugin you can activate in your project. While this is available in UE427, we've made some major improvements to it that should help ensure a more accurate conversion in more cases. The converter is just one step in the process and only converts assets. It won't replace existing systems or components used in the world or blueprints. You'll also want to manually update Blueprint and C++ Cascade references to the Niagara particle systems to ensure they're working as you intend them to. Once the assets are converted, it's likely you'll need to modify the new Niagara system and emitters in the event that some feature of the effect was not properly converted. Further, once you've converted the asset, we recommend making additional modifications to the emitters so that they're fully leveraging the power of Niagara. We understand that this process may be cumbersome and tedious, but we really think the effort is worth it for the additional power of Niagara as well as its performance benefits. World Partition is a new data management and distance-based level streaming system that provides a complete solution for large world management. The system stores your world in a single persistent level separated into grid cells and provides you with an automatic streaming system to load and unload these cells based on distance from a streaming source. While world composition will load levels just fine in UE5, we recommend converting to World Partition since we plan to deprecate world composition in the near future. For new, large worlds, we of course recommend using World Partition. Keep in mind that using World Partition in a map will activate one file per actor, which will store actors in their own separate files in a managed repository within your content folder. This will help reduce source control contention with multiple users able to work in the same level without any issues. Currently, only Perforce is supported by one file per actor for source control, and we hope to add support for additional source control systems in future versions of the engine. You can convert existing world composition levels to World Partition, as well as converting previously non-world composition levels to World Partition. Before converting, keep in mind that any sublevels with level blueprints will be packaged into level instances, along with any references within that level blueprint. Additionally, during the conversion process, some references, particularly soft references, between actors in any level may be lost and need to be reset manually. You can convert a level from the Tools, World Partition, Convert Level dialog. This lets you select the level you wish to convert, and you have the option to convert the level in place. Otherwise, a new UMap file will be created which appends _WP to the end of your level name. Advanced users can customize the conversion commandlet and select that class from here. If you want to see what will occur during the conversion process without waiting for potentially lengthy source control operations, you can use the report-only and verbose options to output a log of the conversion without actually creating any new assets. If any errors crop up during the conversion process, they'll be reported here, so you can address them before properly moving forward with the conversion. The conversion process can take a bit of time, and that depends on the size of the world and the number of actors. For the purposes of this video, I'll speed this up. We'll also include instructions in the resources below for advanced usage of the conversion tool, especially as it pertains to HLODs and source control. Once your conversion succeeds and you open your level, you may find that everything is missing. Don't panic. This is because the editor cells are unloaded by default. All you need to do to see your whole level again is open the World Partition Editor, select all the cells, right-click and hit Load Selected Cells. The editor will remember which cells you have loaded and unloaded, so the next time you open the map, you won't have to do this. In the world settings for your map, you'll now see quite a few options in the World Partition category. Here, you'll definitely want to set the default HLOD layer. This is an asset, and its associated settings will be used when building HLODs for your entire World Partition level. And it can be helpful to have a default value in place which you can then override on a per-actor basis. You'll need to run a commandlet to set up and build HLODs for your level, and we've included some helpful command prompt calls in the resources below to get you on the right path. For the time being, HLODs in World Partition are only visible in Play-in Editor and cooked builds. One thing to keep in mind is that the Unreal Engine now ships with large world coordinates, meaning coordinates are now in double precision to support games of all sizes. Our goal is that this conversion should be seamless and require little to no changes to your content. In version 5.0, we can expect parity up to the float max limit for placed actors. However, there may be some instability beyond that value. We want to empower you to create very large-scale games, and you'll certainly be able to develop them in Unreal Engine 5.0, and we look forward to improving the precision of the system as we further develop the engine. As with many new features in the engine, we first needed to lay the foundation upon which we'll continue to build and improve. Of course, with new major versions of the engine, some features of the engine that were deprecated in Unreal Engine 4 have now been removed from Unreal Engine 5. Firstly, tessellation has been completely removed from Unreal Engine 5 after it was deprecated in Unreal Engine 4.26. Dynamic, GPU-driven tessellation is a powerful feature of DirectX 11 and allowed creators to show high-resolution geometry without the memory overhead that incurred, which was, at the time, extremely limited. As the available hardware improved, memory became less of an issue, and instead GPU cycles have become more important. For the time being, where additional geometric detail is desired, we recommend you instead import the high-resolution geometry you need as nanite meshes. For landscapes, we support high instance counts, so it's possible to author terrain as very high-resolution tiles. Look forward to some exciting developments in future versions of the engine here. We have removed support for gbuffer deferred decals in UE5. This change was made, once again, to lay a foundation that will lead to some amazing new features coming in future versions of the engine. One of the most visible impacts of this change is the removal of the decal blend modes dropdown. Let's take a look at the decal blend modes as they were in UE4 to understand why. The engine now infers the dbuffer blend mode based on the connected input pins. So let's remove those from the list. Then, emissive and ambient occlusion are special draw calls that blend either scene color or SSAO respectively, and we can also infer that information from the connected pins. This leaves us with alpha composite, translucent, and stain. Alpha composite and translucent are already an available selection in the main blend mode dropdown, so that becomes redundant. Finally, the stain blend mode is effectively a modulate type blend, and that's also a blend mode available in the main dropdown. So, when the engine converts UE4 decal domain materials to UE5, it will change the main blend mode dropdown to the appropriate mode based on the original decal blend mode and will infer the correct debuffer decal blend mode based on the connected input pins. As with any version upgrade, some issues may arise that are specific to your project, and there's a few ways and places you can look to find these issues. You can use the Build Map Check tool to highlight any issues in your map. This opens the message log, which is another great place to look for any issues. You can scan the output log, This has been moved to Windows Output Log, or you can access it from the bottom of the editor UI. From here, you can click on Filters and uncheck Messages to show only warnings and errors. Perhaps most importantly, you should package your project for your target platforms as soon as you've upgraded your project to UE5. The errors and warnings that arise here will give you a very clear picture of any issues that could have occurred during conversion. We hope you found this guide helpful in preparing to upgrade your project to Unreal Engine 5. We're so excited to see what you can create with all the new tools and features at your disposal. Thanks for watching.